and welcome to a new video. My name is Mr. Nagy Elraheb, and today's lesson will be about recurring decimals. In an exam, how do recurring decimals come? We expect to find something that looks like this. Use algebra to show that the recurring decimal 0.3 recurring is equal to 1 over 3. Trust me, in a few minutes we'll be able to solve this together. But let's start from the very beginning. What are the recurring decimals? What do they look like? Let's have a look. If I have a decimal like this, 0.33333, and those go forever, we call that recurring. There is one digit recurring here, the 3. So can we write this in an easier form? Yes, we can. We do this. 0.3 and then put a dot above the recurring part. So we have here one recurring digit, the 3. So one dot. What happens if I have 2? Like 0.242424. The repeating part is 2 digits, not just one. Do we follow the same concept? You bet we do. So we have 0.24, and for that we put 2 dots. So now this shows that the 2 and the 4 together repeat. So 24, 24, 24. What if we have 3 digits? Do we do the same? Actually not. There is a little tweak here. For more than 2 digits, instead of putting 3 dots, 4 dots, 5 dots, we will just put 1 dot at the beginning and 1 dot at the end of the repeating part. So when we see a dot at the 2 and a dot at the 6, it means that everything in between is repeating. So we have 0.236, 0.236, 0.236. Okay, so what happens if I have an example like this one? Now, not everything is repeating. Actually, we have a static part or a part that is not repeating. Here we have the 5.2, and then only the 3 is repeating. So this is done this way. We write our 5.23 and we put 1 dot on the repeating part, which is 3. I know some of you have seen this before, but it's better to remember this before we start tackling problems, and we have to understand this. So let's start. Now our first example. It says use algebra to show that the recurring decimal 0.3 is equal to 1 over 3. So the question asks us to change a recurring decimal into a fraction form. Here he told us the fraction we are supposed to find, the 1 over 3. Sometimes he will not tell us what that is, and we will learn how to find it. So let's start. First, we call the given decimal a name. So instead of writing 0.3333, we'll say that 0.3 recurring is called an x, so x equals 0.3 recurring. Then we multiply the recurring decimal by either a 10, 100, 1,000, depending on how many digits are recurring. So in our example here, we have only the 3 recurring, so 1 decimal, so we multiply by 10. Of course, since this is an equation, when you multiply by 10, you multiply both sides. So this becomes 10x on the left and 3.3 on the right. If you are wondering where this 3.3 came from, let's have a look. Remember that this was originally 0.3333. So when we multiply this by 10, it becomes 3.33 or 3.3 recurring. So what's written in the equation is correct. But you have to be fast and know how to do it without showing this extra step. Now we have 10x equals 3.3 recurring. For those two equations, equation 1 and equation 2, we are going to subtract 1 from 2. How is that done? Like this. Equation 2 minus equation 1. So 10x minus x will give us 9x. And 3.3 recurring minus this recurring part will leave us with the 3. So what do I do then? I take the 9 to the other side by division, as you know. So x becomes 3 over 9. When simplified, it gives us the 1 over 3. The very thing we were looking for. So again, how do we change the recurring decimal to a fraction? We move through 3 steps. Step 1, we give it a letter or a name, so x becomes 0.3 recurring. We see how many repeated digits we have. In our case, we only have one repeated digit, so we multiply it by 10. So we have 10x equals 3.3 recurring. Then we subtract 1 from 2, and we get 9x equals 3, or x equals 3 over 9, which when simplified becomes 1 over 3. Let's move to another example and see if we can do the same. Now this is example 2. It says here convert the recurring decimal 0.23 to a fraction. And it did not say what fraction. So the first one was easier. We had a 1 over 3 to look for. This one, we don't really know what to look for. Let's try. Now, as we did before, we give it a name. So let's call 0.23 recurring x. So x equals 0.23 recurring. How many digits are recurring here? Last time we only had a 3, so we multiplied by 10. But this time we have 2 digits. So we multiply by 100. On the left we'll have 100x, and on the right, if I move the decimal 2 points to the right, it becomes 23.23 recurring. Does it make sense? Yes, it does. So what's the coming step? As we did before, we subtract 1 from 2. So 100x equals 23.233, and then we subtract x equals 0.23 recurring. So what do we get? On the left we get 99x, on the right only the 23. So our target is to remove the recurring part, and we succeeded in removing the recurring part. So x becomes 23 over 99. If you try in your calculator to simplify this, you'll find that that's the simplest form you can get, 23 over 99. So this is the equivalent fraction to the recurring decimal. Now it seems like they are always the same steps, but have a look at this one. In example 3, we have something a bit different. It says here 0.3 and a recurring 2, but the 3 is not recurring. So do we follow the same steps? Yes, but with a tweak. Let's have a look. First we call it x. Now that's our usual, nothing new here. Here we have a new step. The decimal has to be exactly near the repeating part. So I want to repeat this, but change the decimal from before the 3 to before the repeating or recurring 2. So we have to multiply by 10. So we need to remove the decimal from here to there. We get 10x equals 3.2 recurring, right? Yes, it makes sense. Now forget about equation 1, completely forget it. Let's move from equation 2. Let's start from equation 2. Now we have one recurring decimal, the 2. So what do? We multiply again by 10. So on the left it becomes 100x, and on the right it becomes 32.2. When I come to the part where I subtract this equation from that equation, make sure not to forget that we are not only removing the recurring part, but there is a 3 to subtract. So 100 minus 10 is 99x, but 32.2 minus 3.2, it's not just getting rid of the recurring 2, but remember that 32 minus 3 is a 29. So when you change this, it becomes x equals 29 over 90. Actually, that's all. Recurring decimals are easy, and they come in our exams every year. It's more or less a well-known problem, and to solve it, it's just as easy as following those steps. So let's wrap up. What are my steps? Step number 1, give it a name. Call it x. Step number 2, make sure that the decimal is exactly near to the recurring part. So if you have to move it by multiplying by whatever it takes, 10, 100, anything that you need to move the decimal to where it stands exactly next to the recurring part. You forget everything and start from here again. Now you have an equation to look at. The number of recurring decimals determines whether you are going to multiply by a 10, 100, 1000. Actually, it's never more than that in the exams. So when you multiply here by 10, it becomes 100x equals 32.2 recurring. Then you subtract your last two equations to get a fraction that is completely without a recurring part. And when you divide this by that, make sure to simplify if it's possible. If you can't simplify, then that's it. So how do I decide that? Simply put it on your calculator and try. If the calculator simplifies the fraction, then don't forget to put the simplest form. If it doesn't, then that's it. You've got the required fraction. Thank you for watching and see you next video.